Hello all, Shane Hall here, crop advisor for BigYield and AgTech. Today we're going to talk about soil sampling. It's that time of the year through the fall months and through the spring, before the crop goes in and after it comes out. We start doing our soil sampling. Soil sampling can be done in many different ways. You can zone sample, you can grid sample, or as many people do, you can just go into the field and take out a single sample out of the middle of that field. Today we're going to talk a little bit about how I go about my sampling and what you can do in order to understand and get more data from the fields that you're farming currently. The other thing we're going to talk about is how to read that soil sample when you get those emails or that paper back from the lab. Some of it can be Greek, and so I have my soil results here with me today, and so we're going to go over that just a little bit as well. So first of all, very basically, how do we soil sample? Well, we go through Midwest Labs, and we'll go into the field, and if we're gridding, we'll take our technology with us, our computer, and we go through the system and we allow the GPS to grid those fields, and then we go grid by grid depending on how big those grids are. Sometimes we do 2.5 acre grids, sometimes we'll do 5 acre grids, and other times we've done 10 acre grids. But you can imagine that the tighter the grid, the more data that you're going to have. And obviously, the more bags of soil you're going to take out of the field as well. So we'll go in, we get our grid set up, and that's after we do the boundary of the field so that we can understand exactly how many acres that we're working with. And once we have that grid set up, we go grid by grid, and we take a sample from around that particular grid spot, and we put that sample in a bucket. We mix all of that around, and we put it in the bag, and we move on to the next grid. So once that field is done, we take that and we label everything. We send it off to the lab, and then the lab does whatever test that we ask them to do. So there are many different tests. There are just basic tests, and you can go all the way from just the basic S1A soil test all the way. You can do as much as you want. They'll test as much on your soil as you want them to, but as you can imagine, it gets more expensive, and the more in-depth your test is. So that's kind of the basics of how we soil sample. And so if you have any more questions about that, feel free to contact me, and we can talk about what would be best for your farm, whether it's a grid sampling, whether it's a zone sampling, or whether it just needs a single sample. In my opinion, I really like the 5 acre grids. You go in, you go into your field, you can have good data every 5 acres, because boy, that soil types can change, textures can change, and all of that within a very small space in a field. And so you get to understand exactly what you have in your field if you take 5 acre grids. And so again, I would love to talk about that more. Now, once you send that sample off, what do you make of the data that comes back? How do you read that? So we're going to go into that just a little bit today so that we can understand what's coming back to us. What do the numbers mean exactly? And we won't get too much into a lot of the jargon, but I'd like to talk a little bit today. We'll start with CEC, organic matter, and pH. So CEC is the cation exchange capacity. The organic matter, you'll see it on your test, it's going to show up as an abbreviation OM, and the pH obviously is going to show up under pH, and that gives us and helps us understand whether our soil is acidic or alkaline. Soybeans and corn like to be in between that 6.3 to 7.2. 7.2 is a little bit high as far as pH is concerned. But within that range, we know that the plant is going to thrive and be able to uptake. We'll talk a little bit more about pH in just a minute. So let's first talk about a little bit about CEC. That's one of the more important numbers. That's one of the more important pieces of data on your soil test, because that's your cation exchange capacity. The lower the number of your CEC, the fewer positive ions the soil will hold. So basically what that's saying is what type of nutrients can my soil hold on to? What's its ability to hold on to those nutrients so that it is available to my plant? And for that matter, organic matter and pH go along in the same boat. Those three items tell me not exactly what nutrients are in my soil, but how much can my soil hold, and what is the soil's ability to hold on to those nutrients so that they'll be available to the roots, to the plant that I have in the ground there. So a lot of what CEC depends on my soil texture. If I'm in a sandy soil, a lot of sand, sandy loams, something like that, and we don't see too much of that unless we're near the river bottoms, we will have a lower number of CEC because that sand doesn't have the ability to hold on to cations, much like a clay type soil would have. Clay is able to hold on to the cations a lot better, but if you have too much clay in your soil, you can imagine that those ions would be tied up, the nutrients would be tied up, because the clay just won't turn loose of them for the plant in order for the plant to get to. So basically, CEC is how available are the nutrients in my plant. And moving on to organic matter, again, it has a lot to do with that very same thing, but different types of soil hold nutrients differently. And organic matter has a lot to do with our mineralization process. Are the nutrients in the soil being broken down? Right? Or the stover in my soil, is it being broken down? The refuse that comes off of the combine following harvest, how is that being mineralized in the soil in order to make the nutrients available to the plant? And so how much organic matter I have really tells me how much or what's available to my plant in that particular soil. Generally, with organic matter, you're going to see on your soil test that they'll credit about 10 pounds of nitrogen for every percentage of your organic matter. And it can vary in soils up and down, but for every percentage of organic matter that you have, they're generally going to credit about 10 pounds of actual nitrogen in that soil when they're suggesting or recommending how much nitrogen to add. So that's cation exchange and organic matter. Moving on to pH. This is something I talk a lot about because your pH will determine whether or not your nutrients can be taken up. If you've got too acidic of a soil, then all of those inputs, the P and K and N, the plant just can't access them. So again, corn and soybeans are going to be between 6.3 or 6.5 and 7.2. I really like to see it in that 6.6 to 7.0 range when we're talking about talk about our pH. You'll notice on your soil test, a lot of people ask this question. They ask about the buffer index, and so you'll see on your soil test, it has a soil pH and gives you that number, and then it gives you the buffer index. See, what happens at the lab is, and this is an important number, a lot of people overlook it, but what happens at the lab is they will take a solution, and that strong solution shows just how easily the pH can be manipulated. Can it be changed easily or not. And so the buffer index measures that. It measures the ability of the soil's pH to be changed. And that means something, because when we're choosing our lime and the place where you get your lime from, your lime outlet, your lime source, or your fertilizer guy, whoever's doing that, he's going to know the CCE of that particular lime, what the calcium carbonate equivalent, and the ability of that lime to change the soil. All of those things go into what it's like in order to manipulate, in order to buffer that particular soil's pH. So the buffer index is important. Is it a tough soil to turn, or is it one that will turn fairly easily? Those three, I talked a lot about those, but those three things are important, because that again is our soil's ability to hold nutrients, to release them to the plant. And so I hope I didn't bore you too much with those particular things. So let's move on to our phosphorus analysis. On your soil report, you're going to notice a P1 weak bray and a P2 strong bray. So most soil tests, you're going to just look at the P1, and when you get recommendations, that's what that is based on. It's based on the P1 levels there. And the lab uses the P2 just to kind of check themselves. It's a quality control deal to make sure that what they're doing is accurate. So that's the point there. So when I'm looking at with my phosphorus, I'm looking to make sure that it's around the 20 to 30 parts per million. And the only other thing you'll notice on your lab report is it'll say L, M, or H, also VH or VL. Those stand for very low, low, medium, high, or very high. So that kind of tells you what vicinity that you're in. But for phosphate, we want that to be around 20 to 30 parts per million. Any more than that, then you're risking that particular nutrient being washed away from that soil, because phosphate is not mobile in the soil, much like nitrate is. Nitrate's mobile in the soil. Potassium is mobile in the soil. And so a lot of times the phosphate has to be put right near the seed, right near the roots, so that plant can take up that nutrient. If it's just sitting on top of the soil and it's not infiltrating, it's not going into the soil or being worked in, then that's why we're losing a lot of phosphorus into our streams and rivers and ponds and different things like that. So that's an important idea to know. Around a 20 to 30 parts per million again. Sometimes on your test you're going to see a high phosphorus. The particular one that I'm looking at right here, it has a very high. All the phosphate values here, their phosphorus values here are said to be very high. I mean, we're even looking at some with 108, 135. So what do we do when we have phosphorus that's that high, or why would that be the case? Well, if you're on a property where you've used a lot of manure, whether it's chicken litter or other types of manure sources, then generally that's an indicator. High phosphate is an indicator that manure was used at some point. Also, zinc can be affected by that, and potassium as well. So when you're getting extremely high values of phosphate, think manure issues. So that's where a lot of times you'll see that. And so on this particular test, we've got some really high phosphorus values here. So when I'm looking at this, I'll know that, well, I don't have to add anything. As far as in the realm of phosphate here. So moving on from phosphate, well, we'll start talking about potash, potassium a little bit. When the potassium, we want to be right around that 200 parts per million. So the value is different there, right? We want to be right around 200 parts per million. And in lighter soils, I'll want to go for a little bit lower target than that. Why would that be the case? Well, in lighter soils, it's more sandy, right? That sandy loam soil, it's not going to hold on to that potassium. So basically, you're putting good money after bad if you're just going to try to too much of a good thing is basically what I'm saying. So if depending on your soil texture, it'll make a difference. That's when we go back to that organic matter, right? What type of soil texture do I have? That's why it matters when I'm making recommendations on these particular nutrients, what my CEC is, what my organic matter is. Those things matter. So potassium, I want to be right around 200 parts per million. I've got a very high, on this particular test, I've got a very high potassium level in this particular soil. Well, this is the same soil that I know that I've got high phosphate in, and I happen to know that this particular soil has had some manure additions to it, and so a lot of times you're going to see that happen. So moving on from potassium, let's talk a little bit about magnesium and calcium. Magnesium, 300 parts per million plus is good. I don't normally haven't seen places where magnesium needs to be added. That usually is not something that happens. Usually and typically they're in pretty good shape. And as far as calcium is concerned, we get that from our liming additions, right? Your calcium carbonate, your lime applications are going to carry your calcium good enough. And now that's not to be said for a lot of your foliar feeds. A lot of your foliar feeds are going to have those magnesium and calcium, and then a lot of the micronutrients in them. That's not to say that is not helpful to the plant in an immediate source. So those things are vital. They're important to the function of the plant. But I don't see a lot of deficiencies in magnesium and calcium in the soil. Let's see. What happens if, this is one thing I wanted to look at, and one thing that also has to do with manure. Chemical fertilizers can cause this as well. What if your sodium levels are up and your soluble salts? So on your soil test report, you're going to look and you're going to see your the sodium levels, and those are going to be important. What happens if those are too high? Well, they can definitely disrupt the uptake of nutrients. They can disrupt the processes of the plant, and so we're going to have to keep an eye on your sodium levels. High sodium is right around 160, and so if you're seeing that, then you may have to add some gypsum to the soil there. Gypsum, it will wash that sodium out of the soil, and in order to get it to safer levels, and that it's important to make sure that our salt levels, our sodium levels are not too high. Now, gypsum is very simply, gypsum goes in and it removes some of the cations from those exchange sites, cations such as sodium and other things, so that it can be replaced with cations that your plant can uptake. So that's just a basic explanation of that. This particular test that I hold in my hand here, it has micronutrients. And again, you can choose all different types of tests, right? You can just get the basic test. And in those basic tests, you're going to get your P and your K, organic matter, cation exchange, and your pH. All those things are going to come in your basic test. But this particular test, I sent out for micronutrients as well. For zinc and manganese and iron and copper and boron. It really gives me a lot of good data on my soil. Now, just because they're micronutrients doesn't mean that the plant just needs them less. The plant still needs those particular nutrients in order to produce, in order to thrive. And so I really need to understand what those particular, how those particular nutrients are doing on my farm as well. That's just don't want the video to get way too long, but that's just some basics of the soil test and how we pull soil samples. I hope you're able to learn a little bit. Again, if you have any questions, feel free to contact me. I hope you all have a Merry Christmas and a Happy New Year.